Good morning. How we doing? How we doing? All right, we are simulating DNA today. Um, Against someone else in computational chemistry class. I'm like practically a TA at this point for that class, but they want to simulate DNA, and so I need to figure out how to do that. Seems like a pretty cool thing to do, honestly. So I said I'd help them. We're sipping on yerba. Oh, so good. Okay, so specifically, he wants to simulate DNA with a linker molecule, and this isn't like, is this even really DNA? I mean, these are just like strings of D and T's on either end. So I guess DNA probably has that, right? You know, I don't think it really matters, honestly. But it's just this really small strand, I guess. It'd be like a double helix, maybe. You're simulating like a double helix. Um, but there's this PEG linker that we need to attach. And to be able to add this, we basically need to create a custom residue. So we need to cleave off this. We need to add the phosphate and then probably add like a carbon, and that'll represent basically the rest of the molecule. And then here we need to add a pride ether and then cut that off, right? And then we have, let's see, one, two, three, four, five, six oxygen atoms. So I've already went ahead and geometry optimized that linker. So you can go to ATB. Yeah, so these are like the initial. So initially I put too many atoms in there. And then the second time I actually had the charge wrong. So along the backbone, phosphate linkers, it's actually a -1 charge, not -2. So we got that. Okay, you just download that. I think I downloaded it. I need to delete some of these files. Um, let's see. Correct mol 2. Yeah, I think this is it. So then we put this into our program right here. So um, I don't know what the charges of the caps should be, so we're not going to do a restrained charge fitting. We're just going to do unrestrained and then cleave off the ends. Um, and I guess we're going to simulate this in Amber. I guess we could do GROMACS actually, but I actually have never done a custom residue in GROMACS. We could first try out Amber. Um, let's see. So I kind of want to delete all of this crap here. Like that's wrong. Yeah, I'm just gonna do that. RM mol 2. Yeah. RM PDB RM. So do we need we don't need the cap atoms. Um, we don't need the XYZ. remove the timer. Okay, and then we can just add this here, just so that everything's all clean and neat. So we'll do touch PEG dot PDB. So this looks like that. Looks good. And then we need to open up Pymol. I should just make an app at this point. Like, put this down there. Okay, drag and drop. So now we need to save this. Sure. Save. Mol2. We'll call it PEG. Mol2. Wait. Why is it doing that? Okay. Let's see if this looks fine. It does. And then we should be able to do PEG underscore mol2. I mean, we've already done this, but we can do it again. Conda. So we need to activate this environment. Nice. All right, so in the meantime, we can check up on some simulations that we've been running in the background. I have to meet with someone at 1. So we got a couple hours. I'll probably get tired before then anyway. Yay, we're running. All right, that's good. So CD, scratch, Dominic, sync handoff. Let's start with TPO. Sweet. So should we go ahead and start trudging out these files? Probably. But I forgot how to do that. Oh, it's this. Okay. Yeah, let's do that. So, boom. We should. I don't think we don't need to do that yet. We can strip these. We can change the name of this to something like that. Kind of a mouthful. I'll delete the date. Maybe sync handoff TPO 42. Yeah, this seems right. And then change this. So basically, we're loading the trajectory that we're creating right now. We are centering it, stripping the salts and water. So we should get out a new trajectory. And then we need the parm7 file to load that trajectory. So now what we can do is cpv traj. Why isn't my computer pressing buttons? There we go. Okay. Oh, it's fast. That's like no time. Okay. Where did Where'd it go? It's not on the left here. Oh, okay, I see. I'm not in AMD. It's in the wrong directory. Now it's probably gonna take a lot slower. Yeah, that's about right. Okay, so this is done. Let's look at the charges here. Do they look reasonable? Yeah, to me they do. I don't really know what to compare it to, but doesn't look like anything crazy. Okay, so at this point, delete that. Now we can use the commands for the custom residue, which should be yeah, here. So yeah, that. All of this should transfer to that. Except we can't do delete. Yeah, how would I load that? I mean, I guess it forced a bond between them, right? Yeah. I think it should be okay, actually. Maybe we could write nucleotides here. Yeah, that might be actually what we do. I'm kind of thinking to myself a little bit. I'm not doing a good job of explaining my thoughts, but I think you'll see what I mean in a second. I gotta sneeze. Ugh. Okay. So let's download that. Goes here, 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 results. Download. Download. Okay, let's read this for the other one. Copy this over. So we'll call this unmodified. Is that how you spell that? Looks like it. Okay, you can do cpp traj. Right. So now we got this transferred over. So let's change these commands real fast. So, or should I just do this in this directory? Yeah, I think so. Yeah. So let's move this in there. cdpg. Okay. So we want PEG, RESP-mol2, PEG. So this will create a .ac file for antechamber. Oh, I see. Nice. Okay, so that created the .ac file here. So now we need to define a .mc file. This is a main chain file. We're basically defining the main chain and things apart from the main chain, which are the capping residues. So it's going to look something like that. Okay, so we can pull up this. Okay. So the tail, how does, what would be the, like, tail for a DNA helix? The tail, you have a 5', 3', two into the molecules. These ends are defined by carbon atoms on the phosphate groups attached. Okay, so the 5', the 3' has an hydroxyl group. So it goes 5 to 3. So I guess the phosphate would be the head. That's my guess. I don't know if it really matters, but so we need to attach it right here. Let me look at this again. Stop. Downloads. So we should probably have this in here too. Okay, so yeah, so that atom right there is that'd be the head. So the head name is O. Uh-oh. I need the specific, maybe it'd be here. Yeah, there we go. Wait. What about the AC file? Do we have an O10? Well, hopefully those go together. Do they? HCH. Okay, they don't. They're the same order, but the different names. So for number 18, yeah. So what I need to do is do antichamber on this guy. And then transfer the charges. I mean, I could just do yeah, so these are the charges right here. I'll just copy this. Hopefully that works out. We'll see. Okay, looks like it did. So, and then let's see if the RSP multi charge is carried over. And then do we have our names? Yep, 09, so that's good. And it should be in the .ac file. Yeah, they're named right. All right. Okay, so this is the head. So the head name will be 06. The tail name would be, I think this, 03. I need to look at this again. So we're talking over here. Now the tail name would actually be C14. So the main chain is all along here. So C11, C10, 05, put 0, C9, C8. Now I'm wondering if I have to do all of that. That might just be enough, we'll see. So we're going to omit atoms P1, O8, 07, O9, and C13. Okay, and over here we are emitting atoms O10, and C14, right? Yeah. So the pre-head type will be a carbon atom, and the pre-tail type, or the post-tail type, I think will be another carbon atom. Wait, what? No, this is the... No, that's the tail. C1. I guess it's that. All right, let's see what happens. Let's do name PG. Oof. Similar. This is just info. I wonder if that means something's wrong. This looks right. Except for that. I think we probably need to include everything in the main chain. So let's get to writing then. O5, C9, C8, O2, C3, C2, O1, I hate when I do that, O1, O1, C7, C12, O4, C6, C5, O3, worst part of the job, C4, and it might not even work, is another thing. C1, we already have C1 there, so that's it. Alright, we'll see if that makes things better. Nope. Still has that stuff. I wonder what that is. I mean, maybe we just carry on, but I'm kind of concerned about that. Just the prep in. Net charge of truncated molecules 0. That's good. Alright, let's just keep going. I've got the heads and tails mixed up or something. Okay. So our FRC mod file. Okay, now we create a T-leap. We want to do something like that. So we want to be able to load. First, let's just see if this will work. I doubt it. Illegal chain specifier 0 and prep n. I have no clue what that means. And prep file. Nan? I can't have nans? Why would it do that? That was probably the warnings that were from that command here. So now we're probably going to have to fiddle around a little bit. One thing I do want to see though before we dive in, this will probably help us a little bit. How do I build a double PEG linker? So it'd be the phosphate of which residue is this? DT? No, sorry. It'd be the phosphate of DA to the sugar to the ribose. All right, let's just give it. Is this even a thing? DA. Let's see what it says. Oh. Let's remove. Let's just see if that'll work. Okay. Whoa. That's pretty sick. I think we're sandwiching things though. But it did something. What if we just did. Well, I need to combine them. Remove the combine command. I just want and also the PEG. Can we just build a residue or something that connects the DA phosphate to the DT ribose? I just want to see what that looks like first. Phosphodiester backbone linkage. Let's try this. Where is this? Where'd it go? I'm blind. Oh, it's saved it to commands. There we go. Okay. So this is DA5. This is DT3. Okay. So it would be like that. Right. So I think I did it right. So DT, yeah, and then that's the ribose. So we parameterized it like that. So we need to eliminate, this is the head right here. So the equivalent would be this, 06. So what is that? The pre-head type is C. I don't know what post-tail, is that just talking about this? Tail name is that, C1. Post-tail type is O10. Let's see what this does. Oh, we're still getting all these crazy things. Then in the prepend, we're getting these nans. We could flip the script, maybe. Let's see. So maybe the head would be C1, and this would be 06. That's all main chain. Oh, this needs to be O, not O10. So this could be O. This could be C. Still crazy stuff. So we're omitting the right names. Let's go back for a second. Delete that. Nah. Number main chain atoms 18. Let's delete this. It really matters what main chain atoms you include, apparently. Things get like weird. So this is probably going to take some trial and error, honestly. But all of these are main chain atoms, so I don't really understand. Let me ask Claude. Why am I getting this? From PrepGen. So then PrepGen, so we do this next. And then we do the tleave script. So we want PG right there. And we need a load gaff. I guess both of those. Illegal unit name, PEG. Oh, I see. We gotta load this stuff. Hopefully we can figure this out. Let's see what it says. Yours was so good. So delete the lines. Why are they there in the first place, though? That's fine. I'm getting 22 errors. Great. Wait, do we make the PDB file at least? Yeah. Ooh, this. Oh. Oh, I see. Huh. Okay, so this. Yeah. We're doing something messed up. So it shouldn't be an O connected to an O, Adam. Hmm. What is this? C1? So let's look at the main chain. C1 is the tail. Oh, you know what? It might be this. Let's try that. That's better. Alright, let's see what this looks like now. Oh shit. It's way worse. Huh. Something strange is happening. Maybe this way was the right way. Okay, so defining C1 to be? The tail or the head? The tail. And this is C1. It should connect to the ribose. And what is it connecting to? The phosphate. So maybe let's assign this to be the tail. And it looks like we need to define the tail to be O10. Or sorry, the tail needs to be O6. So we could just, yeah, I think we switch these around. And this goes C1. So let's run through the commands again and see what it looks like. So we got that. Still got these nans, which is concerning. Do that. We'll do Teely. Okay. Now let's look. Okay. So this looks legit, actually, right here. That looks good. No, it's just that. Why is there a hydrogen? Oh, you know what? I gotta remove these hydrogens. What am I thinking? So, and then C13, yeah, and then I gotta get rid of these. HO3, HO2, HO4. I'm so stupid. O9, C13, HO3, yeah. Is it HO or H03? I think that's a 0. HO4. Okay. Now let's try the commands again. Still get nans. Do this. And then we can do the tleap. One error. Illegal chain identifier. I thought I fixed the chain identifiers. This. What? E? What's the difference between E and N? What is this? H24, H25? What would that be analogous to? Where's H24? First, let me just see if this is the right name. Yeah, these are zeros. Where are they? Oh. Oh, I gotta remove those too, I think. On the other side. O C, yeah. H O 05 24 25. Okay. We still have those, but I removed them. Maybe I gotta do, okay, so the head is, um, what did I say the head was? This is the tail. So post tail type is P1, P. Pre-head type is C1. So this would be C. Yeah, let's do it again. We're still getting those X's. They're supposed to be omitted. Now we're getting even more X's, actually. Um, hmm. Yeah, this T-leap isn't going to work. But I got rid of that. Or did I? Oh. H. God, I'm so stupid. We are goofing today so hard. That's why I need chat here. Okay, there's less errors now. Less infos. We still have that. H23. Where is H23? Right there. On C1. H23s. I mean, I guess it could be equivalent to H10. So what is H10? H1. Oh wait. BE. Let's delete that. Why does this have NAN? 06? Maybe the head is C11. Let's just see what this does. I don't know what's happening. Bond atom problem. Omit name O10. Um, if you look at this, it's supposed to be connected to the phosphate. If I did that. Okay, what if I change that to M then? What the heck? It's probably something simple I'm missing. Alright, let's go to here. Let's download that. Change these names. Um, what if we change these back around? Okay. Delete that. I don't know. What is this? There's something unusual happening here. Maybe I named something wrong. O1. Um, and this creates a new PDB, right? Yeah. See, this is unusual right here. So that got rid of the X's. Let's look at the tutorial real fast. So head, pre-head. Tail, post-tail. So pre-head is what we're cleaving. So the head here is um, 06. Head, pre-head, tail, post-tail. Oh. Why is that like this? Is it the order? I think it's the order. The ends look fine though, I think. Yeah. So it should look like that. So let's redo the order. So let me just delete these. All right, so the head name is 06. So beginning from here, it's C11, C10, O5, C9, C8, O2, C3, C2, O1, C7, C12, O4. There really isn't good instructions for how to create a main chain file. C6, C5, O3, C4, and C1 is the tail. Okay, now we're getting a bunch of crap. There's still that. I don't know what that is. That's weird. Hmm. I'm not understanding. Like, what is that? What could I be doing wrong? This is supposed to be connected to the ribose. One, two, three, four, five. 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. So it's right here. At the O1. Maybe it's just the carbon atoms. That's a long shot, but like what? That has 3 hydrogens for some reason. It's so confusing to me. What was it, C1? C1. H23. C11. So weird. This one stays. Tail, post tail. Tail, post tail. Head, pre-head. Is that what it was? All right. So the prehead's actually O. All right, let's do it again. So we need this in reverse order. I'm gonna just ask him to do it. Put these atom names in reverse order. Okay, so C4, let me just double check. C4, O3, C5, C6, yeah. Let's look at the PDB. It still has that. Like, what is that? Is C2 included? Oh. No way, that was what's wrong. Okay, we have C2 now. Do I include the hydrogens? H9, H2, C2, C3, O2, C8, C9, O5, C10, C11. All right, let's go here. Delete these. H23. Do I just put in the hydrogen atoms? I shouldn't have to. What comes after O6? P1. So this would be our tail. So we have a post tail, P1. H9, H2. Why is it adding this garbage right here? Everything else looks perfect. We are missing a hydrogen here though. On C11. H21. H8. H21. Does that include the hydrogens now? It does. That's getting rid of the X's a little bit. Okay. So let's add H23HO1. BHO1. Then H23. What does that look like now? Got rid of the X's up there. That's encouraging. Let's look at the PDB. So I got that. I think we just need to add the hydrogens potentially. Something to do with HO1. We're including that, right? Head, pre-head, head. There's a bond linking a non-head and a non-tail residue, HO2 in omitted atom C13. O3, O2, O4. Oh my god. Oh, so stupid, dude. Of course it doesn't work still. Let's see what this looks like though. Yeah. Looks way better. So now it's okay. So the prep in. Well, there's nothing missing with the prep in. Let's look at this again. Just we're not getting any more errors. And all the hydrogens look fine. Now we got H8 and H40. Let's look at the prep in again. Okay. Ooh, that's better. Cannot find angle parameter. Okay, we made the PDB finally. Yeah, this looks perfect. Let's get rid of all this crap. A lot of tabs open. I wonder if there's a way to like modify VS Code to where it'll close tabs if it reopens the same one, but this looks promising. So now, all right, what's wrong with T-Lead? Let's do this again. Cannot find angle parameter C707CT. Wonder what's up with that. We're getting close though, for sure. Yeah, that's not going to change anything, right? Huh. Wonder where that comes from. I have no clue. Could be from the main chain file again. Just one error. um, Lost. If I include the hydrogen atoms, I get errors. Tailname 06. Maybe I get rid of that. Nope. Maybe GAF2. Nope. What could be missing? Uh, see what it says. O3 to C1. So the problem is here. Where's C7? Should be up here somewhere. Here. OS CT. What if I remove that? I don't know, man. even fix it. C7 has a different atom type than you suspected. Let's see. I could have named the atoms wrong. Doesn't make sense though. Alright, what if I get rid of all of the O's? Nope, still the same deal. Because if I could get rid of the phosphate. Oof. But that's right though. This has an O. I did not get it. Damn. Um, PDB, where is it? PEG.mol2. Looks like that. File, export structure, export molecule. save. Multu. PG Multu. This looks good. And then what I'm going to do, copy, paste. Then I will copy the commands, paste. Then I'll run the calculation again, I guess. I think it might have something to do with the names of these. They're the same though. It's the exact same. Well, I'll try this. No. That should be right. I'm lost. Okay. Maybe I change this to gaff. Doubt it. So then this AC file has these there. Yeah, now we're getting more errors. Does this work? Yeah. Mm. change this back. Then do the old command. Could that be it? I think the main chain file is right though. No. That's so weird. Maybe I need to add the hydrogens. That's the only thing I can think of. H23, HO1. H10, H14. Let's see what this does, just from here. Yeah, now it's giving fatal errors. If I added it right here. H01 and H23. That's super weird. When you add the hydrogens, it messes up. I don't think it has something to do with the head to tail being backwards. C1, H4, C4, O3, C5, C6, 4, C12, C7, O1, C2, C3, O2, C8, C9, O5, C10, C11. The tail is O6, connected to a phosphate. We remove the phosphate, as well as O8, O7, O9. I do not get it. So yeah, this is that is the head. Pre-head. I'm stopped, honestly. C7 OSCT. What? It's so weird. $18, including head and tail atom. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Let's try and just run the test back. Maybe it has something to do with how we're creating the mol2. Oh, I wasn't even running the ACH mol2. Okay, let's try that then. So instead of RESP, we'll do ACH. Uh-oh. to redo the main chain file based upon these names, potentially. This is C1. This is O. Okay. Let's do that then. C1, tail is 06, so that's right. C1, C2, wait, that could have been it actually. O1, C3, C4, O2, C5, C6, O3, C7, C8, O4, C9, C10, O5, C11, C12. This is already a little different. We have O6, which is the tail. Then we're going to omit name, so we'll start here. O, C, H1, H, H2. Okay. So for the phosphate, it'd be P, O8, O7, O9, C13, '27, '28, '29. Okay. The new PDB. We should have an O there. I don't know why we don't. It's part of the main chain. What? Why is O6 being eliminated? All right, let's just continue on with this. So let's start from the top. Do that. Oh, we deleted our tleap.in file. So now we're getting a lot of no torsion parameters. Start making the PDB. What? ach.mul2. Yeah, it's because of that. No, it's worse. $24, and it was 17. I don't know. So this one was this. All right, let's see what happens now. So let's go back to Amber. $17. Yeah. Head name. Oh. I think I need to delete that. There should be an O atom there. There we go. Yep, now we're back to where we started. again. It's just that one thing. I don't. What angle is it talking about? We're so close, man. Okay. Man, it's worth a shot. So let me just make sure. So we're using the ACH. Yep. I mean, I think there's a command to maybe with Babel. Yeah. It should work though. GAF2. This doesn't change anything. So I'm just going to write a script. I'm desperate right now, so .ach. So renamed There's no way this is gonna work. So now I gotta rename all of these now. CA1. And now this is OA6. So we got CA2. Do we just put A's there? Yeah, it looks like it. Yeah. P is still P. If this works, I will be shocked. Nope, still the same error. I think it has to do with the main chain. The main chain is right though. Charge this. All we need to do is figure this out, and then we're done. What if we just include that? Nope. Man, I don't know what else to do, honestly. All right. God, Amber is so frustrating sometimes. Um, let's go back to the ICH. Let's go back to here. There is no attention needs revision thing. What if I included like an extra atom? So instead of, which I know is going to be wrong. So let's make the oxygen atom part of the bond, but it's going to be like an O-O connection. Like this is connected just fine. Okay, so that worked. So it has something to do with it adding to that. That works. Not that. That's where it messes up. Okay, so I think we've isolated the problem a little bit more. So it messes up this connection. So how about instead of the head being C1, it'll be um, uh, it'll be O. O. Wait. we're doing ACH. Yeah. Okay. So let's change it to O. And then we will include C1 in the main chain. And the pre-head type is C. Make sure that's right. So instead of this, it'll be O. So this will be the head. Pre-head type will be C. We'll include C1 as the main chain. Omit name O. I don't know how that'll work. Yeah, so we can't omit that name now. And so then we have this. We can do delete. So I have 4 errors. So the looks like, yeah, I knew that would happen. So how about we go, instead of back 1, we go forward 1. So instead of the head being C1, it'll be C2. We'll delete that. And then the pre-head type will be C. And then we'll omit C1 also. What am I doing wrong here? This is the main chain. Omit name, the pre-head is C1. Name O. Oh, we gotta exclude these items now. H3 and H4. We're still getting this error. Maybe because this is a methyl. We're definitely doing it right though. And obviously we're not because it's not running, but let's copy this. But this is a methyl too. It's just because of the connection here. Oh, you know what? So this is SP, I mean, this is SP3, but I think it has something to do with like, we need to add these here. Hopefully that won't take long to do, but I think that might be the problem. So I think I replaced these two hydrogens with methyls. I think that's the move. Or it could just include like the entire ribose ring. I'm gonna try that though. I think that's the problem, because like if I do this, right? If I add DT3, works fine. And I am basically including everything here. Then this is a methyl. Yeah, I think I need to probably include this whole ribose ring. That's what I'm thinking. And then add like just a CH3 at the end of this. So let me add both. And take that. Okay, we'll open this. It's worth a shot. Okay, and then what we will do is not editing. Settings. Mouse. Atoms. So we want to basically. Wait, why couldn't we just parameterize this whole thing right here? We'll just try that first. So let's look into here. It's just a lot of atoms is the problem. Yeah, charge -1. Submit molecule. It's going to use some sort of semi-empirical thing, so maybe it won't take very long. Show structure. I want to see it. Why are they disconnected? All right. So yes, I'll just replace this with like a hydrogen. So let me select all these atoms. And that'll be a methyl. I'll have chat open. Okay. So we'll do actions, remove atoms. Okay, get rid of that one. So here we need to add a hydrogen. Yeah. And then here we need to add a hydrogen. There. And that's what we'll submit now. And we could remove that, add a hydrogen. Yeah, let's go and try that. Atoms, boom. There. So we will file, export structure, export molecule, save, right connect records, save as a PDB, and we'll do ATB, save. let's see what this looks like. Oh, so the job estimate got an error, apparently. So how do I turn this into one molecule? Let's just submit this for now. That's one. Boom. Next. I could convert it to a smile string. I think that's what I did. So let's try that and then submit that. We'll put in a PDB, convert that into a smiles. Nice. And then we will convert a smiles where is it? Into a PDB. Okay, now let's look at that. We can just overwrite this. Yeah, that looks good. So we just need to remove that hydrogen. Okay. Action. We just do that. Remove atoms there. Okay. And we'll do file, export structure, export molecule, save, PDB, wait, save. All right, we'll just copy that, submit it to there. One of these has got to work. All right, let me black out my screen and respond to these people first. Say Thursday. Ugh, alright, fine. We're gonna have to pivot and do a lit review. Oh, she texted me. Alright, if she gets back to me, then I'm gonna have to end stream. I think I'll figure this out though, honestly. So here's kind of like the logic here. Because it messes up just on the left side, that means when we parameterize our ligand, we're not accounting for the bonding that's occurring right here. Because technically it's not a methyl, it's a ribose ring. Whereas here, we are modeling like the complete phosphate, you know? So yeah, we have the atom right, but it's not like the connections on the atom are correct. So I think that's the problem there, and that's why we're getting this error right here. So we need to do something like this. Okay, so now we can check the progress. It should get done within like 5 minutes if it just goes. So yeah, looks like that. So in the future, the capping will be a ribose ring like that, and a phosphate with a methyl. I think that makes sense. And then we can get into simulating DNA, actually, but now with the linker. Yeah, and then another thing is going to be building. I mean, actually, that probably won't be too bad. We have to create a mapping. But this is good because at least now we know like how to do custom things, you know. And maybe in the future we can get into restrained charge fitting, but okay. All right. Well, I'm gonna end stream there, so I got some meetings I gotta get to. Peace out. Hopefully next time I stream, we'll have this figured out.